A light bulb produces light by using electricity. Almost every house on Earth has a light bulb in it. We need them in our lives so that we can see in dark, poorly lit areas. The invention of the light bulb created an easier way to light up the night. However, it is not their only use. They can be used as indicators for other electronic products as well. The light bulb is a somewhat simple product to produce, as it doesn't require any rare materials. All the parts of a light bulb are very common. For the most part, they are just glass, metal, and some inert gases. There is no need to create very articulate light bulbs because you can't notice these visuals when the light is on. These materials are what produces the lights that we see all around our world today. Metal is used in the light bulb as a conductor for the electricity needed to power it. The electricity conducts along the metal, causing a small piece of tungsten filament to heat up and start to emit light. The glass bulb itself is used as a container for gases, like most commonly used argon. These gases mixed with the light and heat from the tungsten filament create a chain reaction that leads to the bulb producing large amounts of light. The downside to this type of light bulb is the filament can wear down and break. Solving this problem has been one of the main focuses of designers in past years. There have been many iterations of the light bulb throughout history, the most famous of which was Tom Edison's incandescent light bulb, patented in 1879. This type of light bulb was used for many years and can still be found in homes today. As a product, it is purely functional from the point of its acquisition until the consumer throws it away. Once it is screwed into its light fixture, it will not move until it breaks. To fix the problem of the filament breaking, designers created a new light bulb that causes halogens to emit the light. This causes the filament to last much longer and the light produced to be even brighter. These light bulbs serve a purely functional purpose, fitting well into the engineered product category. Compact fluorescent lights were the next breakthrough in light bulb design. They are much brighter than the previous types and use 25% less energy. They were invented around 1976 when Edward Hammer figured out how to bend the fluorescent tubes. The creation of these bulbs were caused by the oil crises in 1973. This drove scientists and designers to develop a new way to produce light that would use less energy and in turn cost less. CFLs are also the start of the colored light bulb. To change the color of the light, all the producers had to do was change the color of the tube itself. Now we have LEDs. These light-emitting diodes are more efficient, brighter, and last longer than incandescent light bulbs. LEDs are essentially lots of smaller lights producing one big light. These lights commonly produce bright white light that can easily fill up a room. They also use semiconductors instead of a filament to produce light, meaning they will never break, basically making them last almost for forever. Light bulbs make an amazing engineered product. They are there to serve the purpose of producing light, and they do that exceedingly well. Most light bulbs are entirely stationary for their lifespan. Some, however, are used in products, such as handheld flashlights, to produce light in a more mobile setting. In today's world, it is common to see lights that can change into vibrant colors, but for much of their history, this has not been possible. This causes them to remain on a purely functional design path for decades, resulting in not much shift in the way the light bulb works. The physical design of a light bulb is very rarely changed, as you cannot see the form while they are turned on. This also makes the light bulb an engineered product.